The purpose of this experiment is to test how Newton's second laws work and using kinematic equations to find the time it takes to reach the maximum height of the tree. We're going to find the maximum height of the tree. We are going to find the time it takes to reach a certain branch on the tree and the final velocity of the ball when it reaches my hand. The force of the gravitational pull of the football can be found using Newton's second law, which is F is equal to ma. But in this instance, the gravitational pull is equal to m times g because the acceleration of the gravity's pull is the same as a. So the mass of an average football is 0.4 kilograms. So 0.4 kilograms times 9.8 is equal to 3.92 newtons. Okay, the first problem for my experiment is to find the time it takes for the ball to reach the maximum height of the tree. We know that the velocity initial is 17 meters a second. We also know that the acceleration constant is negative 9.8. So using that, we can make a nice graph. VI is 17, VF is 0 because at the maximum height, we put 0 meters per second because it stops for a split second before the decline. We got A is 9.8 negative, T is what we're finding, question mark, and we don't have delta Y, so we can just leave that. The equation we will use for this is velocity final is equal to velocity initial plus acceleration times time, and that will be 0 is equal to 17 plus 9.8 t. Okay, so now we get 17 to the other side. Negative 17 is equal to negative 9.8 t. So now we have to divide 9.8 on both sides, and that will get us 1.73 seconds. T is equal to 1.73 seconds at the maximum height of the tree. Okay, so for problem 2, we are going to find the maximum height of the tree. So we are going to keep the same table we had. VI is 17, VF is 0 because it's the maximum height still. At the maximum height, the object stops for a split second. A is negative 9.8 meters a second. T is now 1.73. And then we are finding delta Y, question mark. So the equation we will use for this is VF squared is equal to VI squared plus 2A delta Y. Okay, so now after having the equation set up, I can just follow it right through. So VF squared, 0 squared, is equal to 17 squared plus 2, 9.8 delta Y. Okay, let's get the calculator. 17 times 17 is 289 plus 2 times negative 9.8. Okay, negative 19.6 delta Y, 0. Okay, so now we are going to move this to the other side. So negative 289 is equal to negative 19.6 delta Y. Now we have to divide negative 19.6 on both sides, and that will get us we get 14.74 meters. The maximum height of the tree is 14.74 meters. Problem 3, we are going to find the time the ball takes to reach 9.58 meters from the release point. The equation needed for this is delta y is equal to velocity initial times time plus a half times a times t squared. Okay? Time to make the table so I can easily plug into the equation and solve. VI is 17. VF, we do not know. Delta y is 9.58. Time we have to find, so question mark. And acceleration is negative 9.8 meters a second. Okay, so now we can plug into the equation. 9.58 is equal to 17t plus a half times negative 9.8 t squared. Okay, a half times negative 9.8 is negative 4.9. So now we have to set this equation to 0 in order to use the quadratic formula. So now the equation will look like 4.9t squared minus 17t plus 9.58 is equal to 0. Okay, now since we need the quadratic formula, we should write it down for reference. It is negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so now with my equation I got from the kinematics, we can now plug in a, b, and c into the equation. So negative b and negative 17 would be 17 plus or minus the square root of 17 times 17 is 289. 289 minus, okay, 4a is 4.9, and then c is 9.58, okay, divided by 2a, so that would be 9.8, okay. 4 times 1/2 times, not 1/2, sorry, 4 times 4.9 times 9.58, and that should equal 187.77. So now it would be 289 minus 187.77, and then we square root. Let's see, 289 minus 187.77. Okay, so the square root of 101.23 is equal to 10.06. So it'll be 17 plus or minus 10.06 divided by 9.8. So let's do plus first. 17 plus 10.06 divided by 9.8 is 2.76 is equal to 2.76 seconds. And then now let's do minus 17 minus 10.06 divided by 9.8 minus 10.06 divided by says that looks better. The other t is equal to 0.71. When the ball passed the branch the first time, it was 0.71 seconds. And when it went all the way up and came back down and passed the branch again, it was at 2.76 seconds. For problem 4, we are going to find the final velocity of the ball as it returns back to my hand. So, the equation necessary is Vf squared is equal to Vi squared plus 2a delta y. Now that we have the equation, let's fill in the table. So Vi is 17, Vf we are going to find. The displacement is 0 because displacement is where the object ends, and even though we throw the ball up, it is landing in the same exact spot as where I've thrown it. So that's why delta y is 0. Acceleration is negative 9.8, and the time it took to reach the top is 1.73 seconds. Okay, now we can plug in Vf squared is equal to 17 squared plus 2 negative 9.8 times 0. Okay. So 17 times 17 is 289 plus 2 times negative 9.8 times 0 is 0 is equal to Vf squared. So now all we have to do to balance this out is just square root both sides, and the square root of 289 is 17. So the final velocity is 17 meters a second as a